Welcome to Engineering Management by Sherwin. In this video, we'll explore standard costing and variance analysis, two essential tools that help businesses manage performance, control costs, and make smarter decisions. Let's begin with the basics. Standard costs are predetermined estimates of how much production should cost. They serve as a benchmark. Variance analysis is the process of comparing these standard costs to actual costs to measure performance. Together, they support better cost control, efficiency, and informed business planning. Standard costs are estimated costs for completing a task or producing a product. They cover direct materials, direct labor, and manufacturing overhead. These benchmarks help businesses gauge how well they're performing. For example, we can set a standard for how much raw materials should cost or how many labor hours a task should take. Setting standard costs is a foundational step in cost control and performance measurement. These costs serve as benchmarks that allow managers to compare what should have happened against what actually occurred. There are two types of standards used in setting costs. First, ideal standards, which represent perfect operating conditions, no waste, no downtime, and 100% efficiency. While motivating, they can be unrealistic for day-to-day operations. Second, we have attainable standards. These are based on efficient performance under normal working conditions. They factor in minor delays and typical production challenges, making them more practical and achievable for most businesses. To set these standards, we can use several methods: historical data, which relies on past performance to project future expectations; engineering studies, which involve analyzing processes and workflows for optimal performance; and market analysis, where we examine current trends in pricing, labor, and materials. Variance analysis is all about measuring the difference between what was expected and what actually happened. We start by calculating the variance. Then, we interpret whether it's favorable or unfavorable. Finally, we perform root cause analysis to understand why the difference occurred. This insight helps businesses respond quickly and effectively. Now let's explore the main types of variances used in standard costing. These variances help managers pinpoint where actual costs deviate from planned or standard costs, allowing for targeted performance analysis and corrective action. We group variances into three main categories: material variances, labor variances, and overhead variances. Material variances help us evaluate how well a company manages the cost and usage of its raw materials. These variances are split into two key components: material price variance and material quantity variance. Let's start with the material price variance, or MPV. This measures whether materials were purchased at a cost higher or lower than the standard. The formula is MPV equals actual price minus standard price times actual quantity. If the actual price is higher than expected, it's an unfavorable variance. If it's lower, it's favorable. Next, we have the material quantity variance, or MQV. This evaluates how efficiently the materials were used during production. The formula is MQV equals actual quantity minus standard quantity times standard price. A positive result here means more material was used than expected. An unfavorable variance. Less usage than standard indicates better efficiency. Together, these two variances help managers control purchasing and production processes, identify inefficiencies, and make strategic decisions to improve material usage and cost effectiveness. Labor variances help us understand how effectively a company manages its workforce in terms of cost and productivity. These are broken into two key components: labor rate variance and labor efficiency variance. First, let's look at the labor rate variance, or LRV. This measures the difference between what was actually paid per hour and what was expected. The formula is LRV equals actual rate minus standard rate times actual hours. If the actual rate is higher than the standard, it results in an unfavorable variance. A lower rate leads to a favorable outcome. Next, we have the labor efficiency variance, or LEV. This assesses how efficiently labor time was used. The formula is LEV equals actual hours minus standard hours times standard rate. Using more hours than planned produces an unfavorable variance, while using fewer hours results in a favorable one. Analyzing labor variances helps managers control wage costs, improve scheduling, and assess workforce productivity, all of which are vital to maintaining operational efficiency and profitability. Overhead variances focus on the indirect costs of production, things like utilities, maintenance, and factory supervision. These are divided into two major types: spending variance and efficiency variance. First, the overhead spending variance shows the difference between what we actually spent and what we had budgeted for overhead. The formula is spending variance equals actual overhead minus budgeted overhead. If actual overhead is higher than budgeted, that's an unfavorable variance. If it's lower, it's favorable. Next, the overhead efficiency variance measures how well we used our activity base, usually labor or machine hours. The formula is efficiency variance equals actual hours minus standard hours times standard overhead rate. This tells us whether we operated efficiently or inefficiently, based on how much overhead should have been applied at standard performance levels. Tracking overhead variances helps identify indirect cost issues and opportunities to improve processes, resource use, and cost control. So why use standard costing and variance analysis? They help control costs, improve decision-making, and evaluate performance. Most importantly, they promote a culture of accountability and continuous improvement across the organization. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe to Engineering Management by Sherwin. See you in the next lesson.